Okay, we're going to jump into lesson 19.1a, which is on graphing the sine function. I've got some stuff jotted down here, so if you want to pause the video and you can write this down, so you've got it set up like me, and then we'll jump into the note sheet, which is on the next page here. So we're just on a blank sheet right now, and then we'll get into the note sheet that is provided on Canvas on the next page. But first, I just wanted to talk about what radians are, because we're going to be dealing with radians. You may have seen this in previous lessons, but I just wanted to break this down a little bit differently for you. So a radian, this is a different way to measure degrees around a circle. So you know that you've got like Fahrenheit and Celsius. That's two different ways to measure the same thing, right? Fahrenheit and Celsius would be two different ways to measure the temperature. Well, we have two different ways to measure our distance around a circle as well, right? We can use degrees, like 180 degrees would be halfway around the circle, or we can use radians. Okay, so it's just two different ways to measure the same thing, and you can go from one form to the other or vice versa. So let's talk about what a radian is. So if we've got a circle here, right, so we've got our circle, and then we've got the radius is this orange piece here, right? So we've got the radius, which is the orange piece there. We should be familiar with that. Now I want you to imagine that we take this radius and we pick this thing up like it's a piece of string, right? So imagine it was a piece of string, right? We measured how long it was. Well, if we take that piece of string and we go ahead and mark that on the outside of our circle, it would be about this long here, right? And then if we measured it again, it's going to be about that long there, right? And then if we measured it one more time, okay, it's going to be about that long there. So it almost gets us all the way to the halfway point of our circle. So if we were to take that piece of string, which is the length of the radius, okay, then we would almost get halfway around the circle there. So then each one of these chunks is one radii. So we have these three radiuses, these radii. So each one of these is one radius here. And then the deal is that, notice it got us almost all the way around our circle. So we would just need a little piece of string right here, okay, a little teeny piece that would connect us halfway around, and that would actually be 3.14 pieces of string there, right? So not quite just 3, we'd need a little bit more, and it turns out to be 3.14 pieces of string. So 3.14 radiuses to get halfway across the circle. So that should ring a bell, because we know that pi is 3.14, right, and on and on and on. And that's telling us that it takes pi radii to get halfway across the circle. And then if I wanted to continue and go all the way around the circle here, okay, it would take me 2 pi radius. So that would be like 6 of those pieces of string, right? A little bit more, because it's 2 times 3.14. So it would be about 6 of those pieces of string. So 6 of those radius strings to get all the way around the circle. And so this is just a different way to measure our distance around a circle here. So then what I want you to really focus on here is that at 180 degrees, that's the same thing as pi in radians, because it takes us pi radius strings to get to halfway across. Okay, and then 360 would be 2 pi. That's all the way around the circle. Maybe you remember the circumference formula, right? 2 pi r. Okay, so that's where that's coming from. And then that means that if halfway across or halfway up the circle here, that's going to be pi divided by 2. And then if we go to 270 degrees, right, then we're going to get, let's see, that would be pi over 2, 2 pi over 2, 3 pi over 2 here. And then 4 pi over 2, which is the same thing as 2 pi. So it's just a different way, like Celsius and degrees, except we're using radians and degrees here to measure our distance around the circle here. Okay, and you can convert any degree measurement to radians, or any radian measurement to degrees using this formula. So to get from radians to degrees, you'd multiply by 180 divided by pi, and to get from degrees to radians, you'd multiply pi divided by 180. All right, so basically I just want you to focus on this piece here, that 90 degrees is the same thing as pi over 2 in radians. 180 degrees, same thing as pi in radians. 270 degrees, same thing as 3 pi over 2 in radians. And 360 degrees is the same thing as 2 pi in radians. All right. And that's going to come into play as we start to graph these pieces here. Okay, so now I'm moving to the note sheet. We're going to go ahead and graph the sine function, and they've got the table already set up for me here. So notice they've got y equals sine of x, and then all they're doing is that they're just taking these x values, so in this case 0, and they're plugging it in for x, and they're evaluating. So they're doing sine of 0, which turns out to be 0. And so that's how they ended up with that first point. Then they're taking sine of pi over 2, and they're plugging that in, okay, and they're ending up with 1. And so that's how they're ending up with the next point there. And you could do that on your calculator, right? You could complete these calculations on your calculator. You just want to make sure that you're in the radian mode instead of degree mode, which is what we've been functioning in. All right. And so anyways, we get this table here. And so what I'm going to do is I'm going to, just like I had my circle, I'm going to zoom back to the circle here. So when we're looking at my circle, I'm starting here at 0. Okay, I'm starting at 0. And then I have kind of these 4 main points here, right? So this is 90 degrees, that's the first piece, 180, and 270, and then 360 all the way around, right? So there's kind of 1, 2, 3, 4 main points there. Well, that's what they're doing here, except they're drawing it on an x and y axis. So we have 0. We've got 0 here. And then we've got pi over 2. And then we've got pi. And then we've got 3 pi over 2. And then we've got 2 pi. And we're going to use those same pieces for all of these here. And then we can go in the other direction as well. So negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Okay. And then they've already got the table filled in for me here, so I'm going to just go ahead and plot these points now. So we've got 0, 0, so that's just right here. And then we've got pi over 2, 1, so that's up to 1, right, which would be right there. And then pi, 0, so now I'm back down here. Okay, and then 3 pi over 2, negative 1, so now I'm down below. And then 2 pi, 0, and we'd end up there, right? So it just kind of follows this pattern where it goes up, and then down, and then back up again. Okay, and it creates this curve here, and we could just follow that pattern straight into the in the opposite direction as well, right? So this would be down below, then up to 0, up to 1, and back down here. So it just kind of looks something like this. Okay, and we'd end up with this sine curve. So sine starts at 0. That's kind of what we got to remember here. Sine starts at 0, so I'm just going to make a note of that. Sine starts at 0. So if we scroll down here, we've got properties of our graph, y equals a times sine b of x. There's a couple things I want to point out and focus on. First, we've got the domain, which they mention here, the domain, and this thing goes from negative infinity to positive infinity, which basically just means that this curve, this sine curve, just goes on and on and on and on and on and on and on forever, right? So it could just keep going and going and going through these different cycles. Okay, so we just go through each one of these cycles here. Then we've got the this a value in the front, and this is going to be our amplitude, which is basically the range. So that's how tall does my graph get, right? So does it go up to 1 and down to negative 1, or is it going to be stretched? Is there going to be a vertical stretch, which we've talked about before? And then it's got the b value, which is inside, and this is going to dictate what the period is for this curve, and the period is how far does it need to go through one cycle. So what I mean by that is, check out this one we did above, right? We went through one full cycle by the time we got to 2 pi, right? So one full cycle is up, back down to 0, down to -1, and then back up, right? So that's one full cycle there, and it took us 2 pi to get through that one full cycle. And that's the standard part. But what might happen is they might start to scrunch this thing up and make it smaller, so you got to get through one full cycle in a smaller amount of time. Okay, so I'm going to go ahead and label my pieces again. Remember, it's pi over 2, and then pi, 3 pi over 2, and then 2 pi. Okay, and same thing in the opposite direction, right? Negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Okay, and so then what we're going to do is for this one, notice that the amplitude is changing. The A value is changing. So this is going to look the same as our previous graph. We're going to start at 0, but then instead of going up to just 1, okay, I'm going to go all the way up to 3 because my value there has changed. And then back down to 0, it's going to follow the same pattern. Okay, then down to -3, and then back up to 0. So it's just going to follow the same pattern where we're going up, down, and back up, and we get that sine curve, okay, and we can follow that straight into the negative side here. So that means that this one is going to start by going down, back up to 0, up to 3, and down to 0. And so we're going to end up with something that looks like this. Okay, and so one period, one curve here would be going from 0 all the way to 2 pi. So that would be one period. Okay, so that's one cycle as we go up, back down to 0, down to -1, and back up to 2 pi. If we get to letter B, it's going to be the same idea here, except this one, instead of going up to start, since it's got the negative sign in the front there, this is going to end up going downwards first. So I'm still going to start at 0, but then I'm going to go down to 1, up to 0, then up to 1, and then back down. So it's just the opposite. So it looks something like that, right? And we can follow that pattern straight into the other direction here. Okay. Okay, and again, we have our period is at 2 pi because we get to one full cycle, right? From 0 to 2 pi, we get to that one full cycle, right? Now as we get to letter C, this is where the period is going to change. So notice we have a B value, right? So we have a number inside. So to figure out what our period is, we've got to use this formula on the other side. It's right here. It says 2 pi over B. Okay, so what I'm going to do is, to figure out what the period is, I'm going to do 2 pi divided by B, which is also 2, which is just going to leave me pi. So what this is saying is that by the time I get to pi, which is right here, that's that second tick mark, right, that we've been using. By the time I get to pi, I've got to go through one full cycle. So I've got to go all the way up, down, and back to 0 by the time I get to pi. Let me show you what I mean. I'm still going to start at 0, 0. Okay, but I know that I need to have 4 main points here, right? 4 little tick marks, 1, 2, 3, and 4. This time by the time I get to pi. So I'm going to add in a couple of tick marks here. Okay, I'm going to add one halfway in between there and halfway in between there. So I've got these 4 evenly spaced tick marks. And now I'm just going to go ahead and draw my graph. So it goes up to 1, down to 0, down to -1, and then back up to 0. And so we were going to get through one full cycle by the time I hit pi. Okay, and we can do the same thing on the other side. So by the time we hit -pi, okay, I should also get through one full cycle. And again, I need these 4 main points here. And so I'm going to go down to 1, up to 0, up to +1, and back down to 0. So I get through one full cycle by the time I get to -pi here. So it's like this thing is just kind of getting scrunched up, right? Pushed from the left and the right, pushed inward from the left and the right there. Okay, get to letter D here. We've got the amplitude, which is going to be 3, right? So that's going to be important. A is 3. So that means we're going to stretch this thing up towards 3, right? And then also my period is going to change, and we're going to do the period is going to be 2 pi divided by whatever my B value is. In this case, it's 4. And so that's going to end up giving me pi over 2 as I reduce it. Remember, pi over 2 is this first tick mark here. Okay, so that means by the time I get to that first tick mark right there, by the time I get to that line, I've got to go through one full cycle. All right, so remember, we need to have 4 tick marks here. So I'm going to zoom this in big time. Okay, so I'm going to make a middle, right? And now I'm going to make one on the left and one on the right. Okay, and we'll go ahead and sketch this graph here. So starting at 0. Now, normally we'd just go up to 1 on this first tick mark, but I got to go all the way up to 3, then back down to 0, down to -3, and then back up to 0. So I'm getting through one full cycle here by the time I hit pi over 2. And that's because my period had changed there, right? That's called the period. The period had changed, and we used this formula for the period, which is 2 pi over b. And our b value in this case was 4, so I did 2 pi over 4, which told me that I got to get through one full cycle by the time I hit that pi over 2 mark there. So my period is pi over 2. And I can do the same thing on the other side. Okay, again, I always need those 4 little tick marks there. So I've got 1, I'm going to split that in half to give me 2, and then in half again, 3 and 4. And so then I can go ahead and draw the other side of this thing. Okay, this time it's going to start down, back up to 0, up to 3, and then back down. And so we end up with the other side of this. Looks something like that. All right. Now let's check out the last one here. Okay. So for this one, notice the period is not going to change, right, for the last one, because it's just a regular x in the middle, which means that I'm going to get through one full cycle by the time I get to 2 pi, so I don't need to scrunch this thing up at all. But notice that my amplitude is going to change. Okay, and it's going to be negative, right, because we've got a negative sign in the front, which means that instead of going up to start, we're going to go down to start. So I'm going to start at 0. Now, normally I would go up here to 1 for my first mark, right? But that's not what we're going to do here. We're going to go down to -2 because that's what my amplitude is telling me, and I've got that reflection. So I'm starting down, back up to 0, up to 2, and then back down to 2 pi. So my graph looks something like this. Okay, and the period did not change, so we get through one full cycle, down, up, and back down, all the way by the time we get to 2 pi, and then I can do the same thing on the other side here, up to 2, down to 0, and then -2, and then back up to 0, and we get through one full cycle here. Okay, and so that's that. Just as a quick recap, everyone, this is a quick recap here. Whatever the number is that's in the front, that tells me how high my graph is going to go, how high up and how high down it's going to go. If it's negative in the front, then instead of starting by going upwards, we would start by going downwards if it's negative in the front. Okay, and then the b value, that's going to tell me what my period is. So notice here's the formula for period, 2 pi divided by b. So you would take that number, in this case it was 4, right? You do 2 pi divided by 4, and you get pi over 2 as I reduce, right? Because 2 over 4 reduces to 1 over 2. And so then I knew that I had to get through one full cycle where I'm going up, down, and back up by the time I hit that pi over 2 mark. And we're going to continue to use these same tick marks here as pi over 2, pi, 3 pi over 2, and 2 pi, because those are the marks on my unit circle, right, on my circle from over here, which would be 90 degrees, 180 degrees, 270 degrees, and 360 degrees. All right, that's a lot of information. We can review that again in class. Thank you for watching.